Google Translate or Bing Translator have been successfully applying statistical machine translation for more than 40 natural languages. In this demonstration, we present semSMT, a web-based SMT tool for source code migration. Developer can use this tool to directly translate a method from Java to C#. User can directly type Java code in the text area. And click the Translate button to see the C# translation output. semSMT also shows the out-of-vocabulary words, which have been never seen in training. They are used to calculate in vocabulary confidence, which is the ratio between numbers of out-of-vocabulary words and total words. The ratio implies that the higher number of words semSMT understand, the higher confidence it translates the code. Let us try semSMT with a more complex case. This example involves various types of migration. First, annotation test in Java is migrated to none.framework.test in C#. Note that the annotation syntax in Java is different from that in C#. semSMT is able to migrate code using different APIs in two languages. For example, method invocation assert equals is migrated to none.framework.assert.r=. Syntactical types can also be different. The method invocation size in Java is migrated to the access to the field count in C#. Object file is consistently migrated to object file path in two locations. semSMT is also able to migrate a usage with a method call into a usage with an element access, which is common in C#. User can modify code in the text area and invoke the translation again. As seen, code in C# is changed accordingly to the new input code. The tool is also able to learn and translate an API usage in Java to an expression with arithmetic operations. To compute the remainder of big decimal division in Java, one uses the remainder method of the big decimal class. In C#, one would use the primitive type decimal in the remainder operator. Interestingly, annotation at override in Java is migrated to the override modifier of a method in C#. semSMT is able to learn differences in syntactic structure. For example, it migrates a constructor initializer inside the method body in Java to a constructor initializer in the method header in C#. This example shows the case when an assert statement in Java is migrated to a method call because C# does not have assert statement. Visit our project's website to see other interesting cases. For demonstration purpose, we also include the translation results for the methods in DB40. Let me describe the core technical details of our approach. The figure shows the basic steps of our migration algorithm. Input Java source code as tokenized, and then used in the decoder to search for the best candidate translation sentences. Decoder utilizes two trained models for the search process. The translation model determines how likely a source sentence and a target sentence have co-occurred in the corresponding texts. And the language model determines how likely a target sentence occurs in the target language. The translation and language models are trained from corresponding Java and C# code. First, Java and C# methods are aligned based on their qualified names and signatures. The corresponding syntactic tokens of the aligned methods will be mapped and trained. The model then performs alignment and training on corresponding semantic tokens within the mapped syntactic units. Semantic tokens include data types and roles of the tokens. At the lexical level, code tokens within corresponding semantic units from Java and C# are used to train the models. Thank you for your interest. Your feedbacks and comments are always welcome.